Hello everyone, wishing you all a very good afternoon. I hope you are all doing well. Good afternoon, Abhinam, Tarun. Am I audible and visible to all of you? Good afternoon, Niharika. How are you? Vashant. Great. Let's start with today's class. Same instructions. You have to send any message, send it on my ID of Astic. Keep your mobile cameras off. Niharika, I am doing fine, beta. I hope all of you are doing fine as well. Keep your mobile cameras off. Sit at a place where you get good network. And stay at a quiet place so that you can hear my voice. Okay. What we were doing in the last class? You all remember? I think we had discussed the Atwood's machine and I had given you a question where you had to find the acceleration of these blocks and the tension in the string. No one has done the question. It's a sad part. Okay. If you have not done the question before, this is the time. Niharika says she has posted me. Probably I did not see it. Maybe she did it just now. Yes, in the morning she did it. Yes, Niharika, your answer is correct. Well done. You have done it correctly. Nice. What about the others? Have you done this question? I'll give you a minute to everyone and then I will discuss this question with Niharika. I'll ask her to unmute herself and then we will discuss the question and see how it has been done. So you have 1 minute from now to solve this question. Okay, I think I have given you enough time to solve this question. Now I'll solve this question. Niharika, will you help me in solving the question? Are you there, Niharika? Can you unmute yourself?
Sir, can you hear me?
Yes, I can hear you. Tell me how this question done. Let me start. We'll start step by step. The first step is, what is the first step?
Sir, we need to make a sketch.
We need to make a sketch. Sketch is already there. What is step number 2?
We need to draw the free body diagram and later we need to
isolate bodies. Bodies are isolated. We have to draw the free body diagram. Let us start with the tension in the string. How many strings you see here?
2 strings. Sir.
You can call them 2 strings. One is string here. One is the string here. The second one can be a string. It can be a rod. Doesn't matter. Okay. We start with the free body diagram of string number 1. What is the tension? Let us call the tension as
T.
T. So T, T, T. Is it correct, Niharika, the free body diagram?
Yes, sir.
So I've drawn the tension in the first string. Let me draw the tension in the second string. What will be the tension here in the second string?
Sir, it's 2T.
Why it is 2T? Because T and T are downwards. So the upward force on the pulley has to be 2T because the pulley is massless. We remember that?
Yes, sir.
Okay, what about the free body diagram of 4 kg block?
Sir, it's 40.
What is 40?
It's the mass into acceleration.
It's M into G, it's gravity, it's the weight. What about the 6 kg block?
Sir, it's 60.
Okay, now we must understand which block will go where. Which block goes where?
So the 6 kg block goes down and 4 kg block goes up
Why?
because 6 kg block is greater than 4 block kg.
The force on the 6 kg block is more than the force on the 4 kg block. As you can see here, here it is 60 newtons, here it is 40 newton, so it will go down. If I call the acceleration of block 6 kg as A, what will be the acceleration of block B? I mean 4 kg block.
So it's also A.
Why it is A?
So because it is the same string.
Yes, the two blocks are attached by the same string, the string being string number 1. As you can see, they are attached by the same string, yellow string, and hence their accelerations are same. So now let us write the equation for block number 1. Acceleration is upwards, t is upwards. Acceleration is upwards, t is upwards, 40 is downwards. What is the acceleration? What is the equation, Niharika?
So it's t minus 40 equals to 4a.
T minus 40 is equal to 4a. Upward minus downward is equal to m into a, which is upwards. I will call it equation number 1. Going on to the block of 6 kg, tension is upwards, 60 is downward, and acceleration is downward. So what is the acceleration? What is the equation of this block?
So it's 60 minus t equals to 6a.
60 minus t equates 6a. That is correct. This is the green equation from the second block. I call it equation number 2. How do you solve these equations, Niharika?
So we need to add equation 1 and 2.
We need to add equation 1 and 2. T will get cancelled out when you do that. And from there, you can get the value of A. What is the value of A you are getting?
So it's 2 meter per second square.
2 meter per second square. You will get 20 is equal to 10A. From there, you will get A as 2. After you get A as 2, you can put it here or you can put it here. You can get the value of T. What is the value of T, Niharika?
So it's 48.
It's
48.
48. That is correct. 48 newtons. That becomes your tension. And these are the answers that we were looking at. Tension is 48 newtons and acceleration is acceleration is 2 meter per second. I have written it must be second square. These are the answers that we were looking at. Do we understand this? Everyone, I'm asking everyone, do we understand this? Am I visible, audible, visible to all of you? Okay, I just feel that I got stuck somewhere here. Okay, think I got stuck here. I'm just checking whether everything is working fine or not. What is there? Let me just. Okay. Okay. So that is how you have to do it. Can I give you another question? The next one. Are you all ready for this? How many of you are? How many of you got the answer for this one? Please raise your hands. Vishal, Vasant, Tarun, Niharika, BPC 1303. How many of you got the answer? Only 2 people got the answer. What about the others? No, no one got the answer. Tarun, Vasant, what happened? What you did not understand, beta? Ask. It is good to clear your doubts in the first instant, because then you will not have problems later on. So I request you, if you have a doubt, please clear it now only. Otherwise, it becomes a bigger doubt and you will face trouble later on. Okay, I'll start with the next question, and the next question is there on your screens now. Again, you have to find out the acceleration of the block and the tension in all strings. How many strings do you see now here? Anyone? How many strings do you see now here? I can call this as string number 1. I can call this as string number 2, and the third one could be a string or a hinge or a rod. I'll give you 2 minutes to solve this problem. Follow the steps, solve the problem. If not, I'm always there to help you. 2 minutes, I'll keep quiet. How many of you are trying the question? Can you raise hands and tell me how many of you are trying the question? No one? 3 people have raised hand. I'm very happy. Abhiram, Niharika, Tarun, well done, beta. What about the others? Roshan, Vishal? See, I always keep on telling you, and I'll repeat, answers don't matter. Never ever in my life am I concerned about the answer. I'm more concerned whether you are trying or not. Because once you try, put in your hard work, I'm sure that you can get the answers. You will get the answer. I'm not sure. I'm 100% confident that you will get the answer. But you'll have to be persistent. You'll have to be working hard. 1 more minute. Okay. Let me start with my thing as well. Step number 1, draw a sketch. Sketch is there. Step number 2, isolate all bodies. Isolated. I'll probably isolate one more if I feel so. Step number 3, draw the free body diagrams. I will start with tension. Let me call the tension here as T1, 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 and T1. So this is T1, T1, T1. This becomes 2T1, 2T1. I've already told you. Now, string number 2 and string number 1, in between there is a mass, so the tension will be different. So I will call it as T2. I will call this as T2. Tensions are marked. So far, so good. When you all raise your hands and tell me, sir, we have done up till here. So far, so good. Niharika has done up till this point. What about Abhiram? Tarun? Okay, well done. Now, once we have done this, this was the difficult part of it. Now, let us go to the easier part. Let us now draw the free body diagram. Then let us start with the 6 kg block. The only other force acting on this 6 kg block is the gravity, 60. I get the free body diagram of block 1. Y-axis will be like this. X-axis will be like this. No force on X-axis. We have done it so many times. First of all, you have to understand, where is this system going to move? Where is this system going to move? Can anyone tell me? How will this system move? It is very simple. You can see it straightforward. You can see it. Where will this system move? How will this system move? Anyone? The 6 kg block will move downwards. Yes or no? And this 3 kg block and 1 kg block will move upwards. If this 6 kg block moves downward with an acceleration A, 3 kg block will move upwards because they are attached to the same string, string number 1. When 3 kg block moves upwards, 1 kg block also moves upwards with the same acceleration A because they are attached to the same string, string number 2. Do we agree on this? Can I have some reason that we agree on this? Up till here. So far, so clear. Now is the easiest part. Just write the equation. I will start with this gentleman, 60 downwards, T upwards, A downwards. What is the equation? You will say the equation is very simple. Equation is 60 minus T1, yes, Niharika, is equal to 6A. That is the equation. The green one, we all know the green one. Don't you worry. Now let us move on to the second one, second diagram, second free body diagram. Let me go here on the 1 kg block. The only other force acting is 1 into G, 1 into 10, that is 10. Let me now write this equation. 10 is downwards, blue 1. T2 is upwards, blue 1. Acceleration is upwards. How does the equation of this block look like? Again, you will say it's a very simple. T2 is upwards, minus 10 is downwards, is equal to 1A or simply A. You can also write it as 1A, not a problem. Oops, wrong color. The blue one. Now comes the third one. Now, since the block number 3 is in between, so what I'll do is I'll just take it and draw the free body diagram again here separately so that I don't get confused. T1 is here upwards, T2 is here downwards. As you can see, T1 is upwards, T2 is downwards. There is one more force, which is gravity, which will be downwards, which is 30. Now you will say, sir, two forces are downwards, one force is upwards, it must go downwards. No, that's not correct. That may not be true because the upward force can be greater than the downward force. Here, as you can see, the pink one, you have assumed, you know that it is going upwards, upwards, upwards. So you'll have to guide the arrow here upwards so that you don't make a mistake that it is going downwards. So now let us write the equation. T1 is upwards, A is upwards, 30 is downwards, T2 is downwards. What is the equation for this block? Anyone? T1 is upwards, 30 is downwards, T2 is downwards. The equation is T1 minus 30 minus T2 is equal to 3A. I can call this as equation number 1, I can call this as equation number 2, and I can call this one as equation number 3. Are you all there or have I lost you in between somewhere? This is equation number 3. So far so good? Yes or no? Can I have some reason that so far so good, sir? We have made this equation, sir. You may have called T1 as T, you may have called T2 as something else, doesn't matter. These are just names. Names don't matter here. What matters is our karma. Now karma is to give them names. How will you solve this equation 1, 2, and 3? Remember the golden words. Add 1, 2, and 3. Once you add 1, 2, and 3, once you add 1, 2, and 3, everything gets cancelled. T1 gets cancelled, T2 gets cancelled. On the left hand side, you will have 20. On the right hand side, you will have 10A. From there, you will get A as 2 meter per second square. You will get A as 2 meter per second square. As soon as you get the value of A, you can put it here in this equation to get the value of T1. You can put it here in this equation to get the value of T2. Can anyone tell me what is the value of T1 coming? Can anyone tell me what is the value of T1 coming? What is the value of T1? What is the value of T1? The value of T1, Yarika, yes, is 48 newtons. Congratulations if you have got this answer. You put the value of A in equation number 1. You can also put the value of A in equation number 3. If you know T2, you will be able to get the value of T1. Can I now have the answer for T2? Oops, wrong color. Can I now have the answer for T2? What is T2? How much is T2? It's very simple. T2 is 12, T1 is 48, T2 is 12. You can also check your answers by putting them in equation number 3. It doesn't matter. You will always get the same result. Do we understand this? Can I have some reason that we understand this, sir? No problem, sir. This is good. You understand this? Don't worry, sir. We can do this, sir. Yes, sir. No, sir. Better you die. Better I go, sir. Better you go, sir. We understand this? Great. So what do I do now? Is I give you another question. Are we ready for this? Have you understood this question? Everyone in unison, please tell me. Yes, sir, we have understood this question and we are ready for the next one. And the next one looks like this. And I urge you to draw the diagram with me so that you don't make a mistake and you don't waste time. And now I have made the diagram like this. This is 15 kgs hanging like this. And this is 20 kgs kept on this inclined plane. I have three questions here. What is the acceleration of the blocks? What is the tension in the string? And what is the force, normal reaction force from ground? Which block this N will act on? Anyone? On which block will this normal force act on? Yes, it is correct. It will act on the block 20 kgs. Here is your chance to solve a question and become heroes. Keep quiet for 2 minutes. Your time starts now. How many of you are trying the question, beta? I'm back. How many are trying the question? Can I have some raised hands? Only 2 people, not good. Yes, the number is increasing. Well done. Okay. 1 more minute. Okay. How do we solve this question? It's pretty damn simple. Follow steps. Step number 1, sketch, already there. Number 2, isolate all bodies, already isolated. Number 3, draw free body diagrams. I start with the tension T, 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 and T. Done. Tension done. Let us now start with this 15 kg block. 150 newtons is the force here. Let me start with the 20 kg block. 20, 200 Newton is the force here. Normal reaction is the force here. Now remember, for this block, the x and y axis are like this. This is my y axis. I hope everyone remembers this. And this is my x axis. I hope everyone remembers this. Now, as soon as you get this x axis and y axis, this 200 is not along x and y. So you must resolve it. This becomes 200 sine 37. Sine 37 is 3 by 5. 200 into 3 by 5 will be how much? I think it will be 120. Am I correct? And this one will be 180 or 160. Am I correct? 120 and 160. Am I correct? This 120 is 200 sine 37. And this 160 is 200 cos of 37. As soon as I have resolved these forces, this 200 does not make any sense. So I remove this 200 so that it does not create any confusion in my head. Now we have to understand in which direction the system moves. There are 2 possible directions. The one possible direction is the red one. This one goes down and this block goes up, the red one. The other direction is the blue one. This one moves up and this one goes down. The blue one or the red one? What will be the direction of motion? The 15 kg block moves down or 15 kg block moves up? Which one is the direction? Tell me. The red one. Niharika, why is the red one direction? Unmute yourself and tell me.
Sir, because the force acting on the 15 kg block is greater than the 20 kg.
Yes. The force which is trying to pull it down is 150. But here the force which is trying to pull it down is only 120. Do not get confused by this 20 kg. 200 Newton is not trying to pull it down because 200 Newton is getting cut into 2 parts. One is 120 and other is 160. So far, so good. Do we understand this? Can I have raised hand that we understand this, sir? The most important aspect of this question was to understand how this system moves. 150 is pulling it here. 120 is pulling it this way. 120 loses. 150 wins. And hence, this blue thing is out of the picture. So I'm just cutting it. I'm not moving it out. I'm not erasing it. I'm cutting it so that we understand that we have cut something. Once we have this, then the party is almost over. We just need to write the equation. One equation will be along y-axis. Whatever happens, this block is not going to move along y-axis. What is the equation along y-axis? Can anyone tell me? Niharika, unmute yourself and tell me what is the equation along y-axis. N is upwards, 160 is downward. So the answer is N is equal to 160. One more thing I forgot to ask you. If this block moves downward with an acceleration A, 15 kg block moves downward with an acceleration A, what is the acceleration of the 20 kg block upwards? What is the answer? A, Niharika says. Why Niharika A? Because both are attached by the same string. So now I will write the green equation. Green equation. T is upwards. 120 is downwards. I hope all of you can see. And A is upwards. That becomes my equation along x-axis. That becomes my equation along x-axis. Can anyone tell me what is my equation along x-axis here? What is my equation along x-axis here? T is upwards. 120 is downwards. A is upwards. What is the equation along x-axis? T minus 120 is equal to MA 20A. That becomes my green equation. Normal is equal to 160. That becomes my pink equation, whatever color it is. Do we all understand this? Do we all understand this? Let me call this as equation number 1. Do we all understand this? So far, so good. Can I have some reason that we understand this, sir? So far, so good. No? Have I lost you somewhere? Vishal, Vasant, Tarun, are you there, beta? Great. The only thing that is left is the block which is hanging. We get into this block. Blue T is down upwards. 150 is downwards. Acceleration is downwards. Give me the equation fatafat. What will be the equation of this block? T is upwards. 150 is downwards. A is downwards. Niharika comes up with an answer. 150 minus T is equal to 15A MA. That is exactly correct, beta. Well done. That is the equation I got in blue. I write it as equation number 2. How do I solve it? Old method, nothing new. I will just add equation number 1 and 2. Once I get equation number 1 and 2, T will get cancelled. What will I have is 30 on the left hand side and I think 35 on the right hand side. So my acceleration becomes 30 divided by 35, which I assume is 6 by 7 meters per second square. Once I get the value of acceleration, don't need to worry. I just put the value of acceleration in any of the equation, either here or here. I would get the value of T. I will leave that for you to solve and get the value of T. That was how we needed to solve this question. Do we understand this? Can I have some raised hands that we understand this, sir? No one understands this? Not good? I'm waiting for your hands. I'll again repeat how I've done this question. Step number 1, draw a sketch. Step number 2, isolate all bodies. Step number 3, draw free body diagram. Step number 4, write all the forces for the 15 kg block. T is upwards, 150 is downwards. For the 20 kg block, 200 is downwards, N is like this. Then I assume X and Y for this block. 200 is going like this. I resolve 200 into 120 and 160. I take out that 200. Now I know 150 is trying to pull it here. 150 is trying to pull it here. It will go in the direction of 150. So 15 kg block moves down. 150 is downwards, T is upwards. 150 minus T is equal to 15A becomes the equation for 15 kg block. N is upwards, 160 is downwards. 20 kg block does not move along y-axis, so N becomes 160. 20 kg block is moving upwards, T is upwards. T minus 120 is 20A. That is the equation along x-axis for the 20 kg block. I add both the equations. 30 is equal to 35A and A becomes 6 by 7. Do we understand this? Can I have raised hands? Niharika has come up with the answer for tension as well. So I'll assume that answer is correct. She is telling me, sir, tension is 137. So I'll assume that is correct. She must have calculated it correctly. I am not good with calculations, so I don't do it. I leave it for you guys to do it. Do we understand this? Can I move on to the next question? Are we all ready for the next question? I have some raised hands. That is a good sign. Raise hands is always a good sign. Raise hand means that we are ready. And you should be ready for questions. And this question comes right now, right here. In this year's NEET, the questions level was a bit on the difficult side. And that is why I'm giving you this question. I always do this question because this is a question taken from, inspired from one of the IITs that I gave in the year 1997. The only difference is that this question does not have friction. My question had friction. So this is the most difficult question probably that they can make in this chapter. And that is why I have given you this question. And the question goes like this. Two blocks M1 and M2 are placed on a smooth inclined plane as shown. As you can see, block number M1, whose mass is root 3 kg. Block number M2, whose mass is 1 kg. One angle is 60 degrees, the other angle is 30 degrees. If they are released from rest, find number 1, acceleration of the block. Number 2, tension in the string. Forget about this part. We can do it later on. So these are the two questions that I am looking at. This is the question taken from your notes. Question number 40. I'll give you 2 minutes. Think about this. Give me the answer. Meanwhile, I'll prepare my part of the answer. I hope everyone is trying the question. How many of you are trying the question? Please raise hands. Okay, I will not disturb you. Just try the question. I hope. For me, what matters is that you try the question. Nothing else matters. It's a very famous song, Nothing Else Matters. When I was of your age, I used to, not your age, maybe 3 or 4 years elder to you. Nothing Else Matters was one of my favorite songs. So I used to listen to it a lot. It was it was sung by a rock band called Metallica. Nothing Else Matters. One of my favorite songs right now for you. Nothing else matters. The only thing that matters is the question which is right now on your screen. And I have drawn the diagram for you. I have drawn the diagram for you here. I hope you are trying the question, right? Okay. How are we going to solve this question? Step number 1, draw a sketch. Sketch is already there. Step number 2, isolate all bodies. Bodies are isolated. Don't have to isolate anything else. Step number 3, draw the free body diagram. Let us start with tension. T, 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 T. Tensions are done. Let us start with the free body diagram of block 1. 1 into G. G is 10. 10 goes downwards. Normal reaction N1 goes upwards. Now you must remember that the X and Y axis for this block will be like this. This will be your Y, this will be your X. I hope you remember this. So I have to resolve this 10 kg into 2 components. I'll resolve it. This becomes 10 cos 60. Cos 60 is 5. Cos 60 is half. So 10 cos 60 becomes 5. So 5 goes here. 10 sin 60 is root 3 by 2. 10 into root 3 by 2. So 5 root 3 goes here. As soon as I resolve them, this 10 goes away. Am I clear? So far, so good. Can I have some raised hand? That, sir. Yes, sir. So far, so good, sir. No problem, sir. Only one student seems to have understood this. What about the others? Great. I get my attention now to the root 3 kg block. 10 root 3 mg is the force here. Normal reaction N2 upwards. Again, I must realize that for this, the y-axis will be like this and the x-axis would be like this. So I'll have to resolve this force 10 root 3, 10 root 3 sine 37, sine 30, 10 root 3 cos 30, sine 30 is half. So 10 root 3 multiplied by half, it becomes 5 root 3. 10 root 3 multiplied by cos of 60. Cos of 60 is root 3 by 2. So this becomes, I think, 15. As soon as I get this, there is no need for this force and I can take this force off. So far, so good. Can I have some raised hand? Do you understand this, sir? Now you will have to understand in which direction does this system move. There are 2 possible directions in which this system can move. The green one, this moves here. The green one, oh, let us call it up this one. The purple one, this one moves here and this one moves here. 1 kg moves like this. Root 3 kg moves like this. Or the blue one, 1 kg moves like this. And root 3 kg moves like this. So which one is the correct option? The bluish one or the purplish one? Whatever color it is. I'm colorblind, I don't know the name of the colors. Which direction will the system move? In which direction will the system accelerate? So to find out that, you have to find out what is the force on this side and what is the force on this side and what do you see? What do we see? They are equal. Yes, beta, they are equal. So if they are equal, what does that mean then? It means that the system remains at rest. The system remains at rest. Nobody goes nowhere. So this gets cut. This gets cut. This gets cut. And this gets cut. And the system remains at rest. Can I have some raised hand that we understand this, sir? Great. Now the system remains at rest. Now let us write the equation. The green equation is for this block along y-axis. This is the equation along y-axis for this block. Can I have the equation from anyone? What will be the equation for y-axis along for this block? N2 is upwards, 15 is downwards, N2 becomes 15. That is the green equation for this block. I hope everyone got this. Yes or no? Seems yes. Let us move on to the equation of y-axis. I'll use the blue color. 5 root 3 is here, 5 is here. The equation along y-axis, no, the equation along x-axis becomes t is equal to 5 root 3. Are we all there with me? The blue equation. The blue is blue. Blue is blue. X-axis is blue. Green axis is yellow. Green axis is yellow. Yellow. Green is y-axis. Okay. Now let us move on and use this color. Whatever color this is. It looks pinkish, so I call it pink. What is the equation? This is the equation along y-axis for this block. What is the equation along y-axis for this block? N1 is equal to 5. That is the equation that I'm getting from this one. That is the equation for this block. So far, so good. Can I have some raised hands? That yes, sir. We understand that, sir. No problem, sir. Now let me write the last equation. This is 5 root 3. This is t. The block does not move. So I have this equation. Again, the same equation. T is equal to 5 root 3. This is the equation along x-axis for this block. And I get the same equation from the x-axis of the other block. And that ends our answer. So the normal reaction for block root 3 kg is 15 newtons. The normal reaction for the block 1 kg is 5 newtons. Tension in the string is 5 root 3 newtons. And the acceleration of the block is 0 because the block remain at rest. Can I now have raised hand from all the kids that we have understood the question, sir? So far, so good, sir. It was a difficult question, sir, but we have managed to find a way to solve it. That's great. As I always keep on telling you, beta, that what matters is trying the question. What doesn't matter is whether you get an answer or not, because with time, I'm sure you will get the answers. I'm not worried about the answers in the beginning. I'm more worried about the process that you are following in the beginning. Shall we move on to the next one? How many of you are ready for the next question? Please raise your hands. Okay, people are ready for the question, and here comes the next one. This is a question which a similar question can come in the exam word to word. Now, up till now, what we were doing was our string did not have any mass. Now, this question can be thought of as a string with mass wala question. Now, instead of a string, because it looks very awkward if you call a string with a mass, instead of calling a string with a mass, they have called it a rod of length L whose mass is M. Mass is not given because mass will get cancelled overall. So mass is not given. So the question goes like this. A horizontal force is applied on a uniform rod of length L, mass M, kept on a frictionless surface. Find the tension in the rod at a distance x from the end where the force is applied. So basically what they are asking you, what they are telling you is they have applied a force F here on this end. This is the end where the force is applied. This is the end which is known as the free end, where no force is applied. So this is the free end. I hope you understand the terminology of the question. So you apply force F at one end and you don't apply anything on the other end. That is known as the free end. The length of the rod is L. The mass of the rod is M. You don't need it because it will get cancelled. You have to find the tension or force in the rod at a distance x from the end where the force is applied. That is the question. Similar question can be made for a string. Instead of calling it a rod, I can call it a string. You have applied force at one end of the string. You have to find the force or tension in the string at a distance x. Time starts now. I hope you have understood the question, everyone. Yes or no? Everyone understands the question? Can I have some raise hand that we understand the question, sir? The first step is definitely understanding the question. Without even thinking of solving it, you must be able to understand it. Do we understand the question? I'll give you a minute to solve it. Okay. Once I get this result, you can use this result straight away. Don't have to worry about how I got the result. You can use this result. I'll give you a minute to think about this. The first thing is definitely to draw a free body diagram. So it looks like this. I'm not worried about the y direction wala forces. You can also draw the y direction wala forces. This would be kept on ground. So reaction will come from ground. Normal reaction n upwards, weight downwards, n will be equal to ft. We are not concerned by that. So they're not asking the normal reaction. Now, remember, this end is the free end. Do we understand this end is the free end? There is no force applied as this end. Now I'll solve this question in two ways. You will see. So I'll just make a small here. This is method number one. Method number one. I'll solve it in red. Then I'll solve the other one in a different coloring. Now what is method number one? So basically this rod is an entire one body. I apply a force F on this body. I apply a force F on this body. What will happen to this body? This body will accelerate. Yes or no? This body will accelerate. Yes or no? Can I have some reason that we understand this, sir? Yes, sir. Now, look at the forces. F is acting in the forward direction. Acceleration is in the forward direction and there is no force on the other end. I will simply apply the equation here. How does the equation look like? Method number one. I'll solve it in green. F is equal to ma. Yes or no? Yes or no? Do we agree on this? F is equal to ma. Okay. So from here I can find the acceleration of this block. The acceleration of this block will be F by m. The acceleration of this block will be F by m. Do we understand this? In green, everything in green. Acceleration of this block will be F by m. Now, once I get the acceleration of this block, what I will do, I can do this in again two different ways. I'll just do it. Let me draw the free body diagram of this X length. Let me draw the free body diagram of this X length. Now, what is happening on this X length? My force F is acting like this, and other force is coming from the other end, which is pushing it. Let me call that force as T. Basically, I have to find the value of this T. Do we understand this? I'll have to find the value of this T. Yes or no? I have to find the value of this T. I have drawn the free body diagram of this small section. The acceleration is A. Yes or no? The acceleration is A. Yes or no? Now I look at the equation. F is forward, T is backwards, acceleration is forward. What is the equation of this block? What is the equation of this block? F minus T. F is here, T is here. F minus T is equal to iska mass m dash into acceleration A. Iska mass m dash, where m dash is the mass of this body, into A. Now, how much is the mass of this body? How much is the mass of this body? How much is the mass of this body? Total mass is m. It is mass of the entire body of length L. So mass per unit length is L, mass divided by length. If I multiply it by x, I will get the mass of this portion. This is known as a linear relation. This is the rod. The length of this rod is L. The mass of this rod is m, and it is uniform. So if I have half of the rod, the mass is m by 2. If I have 1/4 of the rod, the mass is m by 4. So how do I get it? M divided by total length L multiplied by the length of this portion. Do you understand this? That is how I found out the mass of this portion of length X. Total mass is M. I have divided it by total length, and then I have multiplied it by the length of this section. Do we understand this? I just put the values here. I just put the values here now. F minus T is equal to m dash is m by L into x. Value of acceleration is F by m. So m and m gets cancelled, and I get the tension in this block. Tension in this block is F minus F into L, F into 1 minus x by L. That is my answer for tension as a function of x. Tension as a function of x. You must remember this answer. Now, there's another way of doing the same question, and that is very simple. That is very simple. I will give you time to solve it by the second method. Now, what is the second method? I'll just tell you. Here the force is F. Here the force is F. At this end, the force is 0. So it's a simple question. One end force is F. Another end force is 0. Apply common sense. What will be the force at this point? What will be the force at half point? F by 2. What will be the force at a distance 3 by 4? F into 3 by 4. What will be the force at a distance of 1 by 4? F into 1 by 4. So from there, you can get the answer. Am I clear? So this is how you can get the answer. On one end, the force is F. On the other end, the force is 0. So from this end, you can easily find the force, subtract it from this end. The formula becomes f at any distance x. If I call that f as t, that will be equal to 1 minus x by L. To remember this formula. Am I clear with this formula? How I've derived it? When I put x as 0, I come to the first end. The tension becomes equal to F. When I put x as L, I get tension as 0. You can put the value of any x. You will find the value of tension in the rod at that point. Remember this formula. Can you do that for me? Can I have some reason that we've understood this, sir? Niharika understood this. What about others? One end force is F, another end force is 0. What is the force at a distance x? It's a very simple question. A question that has got to do with maths. You can just remember this formula. You don't have to solve the entire question. As you can see, solving the entire question will take some time. So what you got to do, you just remember this diagram. Just remember this diagram and you should be able to remember this formula. On this note, I will wind off this class. I'll meet you again in the next class. Till then, I hope that you will study and we will meet in the next class. If you have any doubts, you can ask me. I hope you have enjoyed today's class. Remember this formula. It will help you in your exams. Take care. Bye-bye.